Alright guys, we are almost done. All we need to do is to find a final answer for this JWT in terms of just gamma. We want to eliminate this discount factor eta because it's the last thing that we don't know. We know that gamma is like a risk aversion coefficient. It's related to the first derivative over the second derivative. It's kind of like an Euler equation. But we don't know anything about this eta, so we want to solve for eta in terms of r and lambda and gamma, and I have not written lambda squared here. Alright, let's do it. So we're going to use our optimality condition, this one, and we're just going to plug in the things that we computed here and here. So we'll get 0 equals r plus, nope, 30 seconds into the video, we're making mistakes. Eta divided by 1 minus gamma plus 1/2 1 over gamma lambda squared, and we want to solve for eta. So we compute that eta is equal to 1 minus gamma r plus 1 over 2 gamma 1 minus gamma lambda squared. Now if we factor this, can we make it more beautiful? Let's try. Eta is 1 plus, geez, oh Pete, 1 minus gamma r plus, let's put the lambda together with this, 2, and then minus lambda squared over 2. Is that prettier? No, it's not prettier. So let's not do that. We'll just leave it like this. Let's put the lambda here and then leave it in this form. So that's our eta. Great. Now we need to take eta and plug it into JWT, and we will have achieved, we'll have found the optimum trajectory here of wealth accumulation. This is the function that will maximize our happiness at every step throughout our lives. I wish I had a function like this. T minus t, w 1 minus lambda minus 1 divided by 1 minus gamma. And that is the answer. Okay, so what did we learn? By looking at this, we can't really say anything. I mean, whatever, we found an answer. Things to note. The portfolio P star is time independent. And that's because our coefficient, the parameters are time independent. Remember that lambda is equal to, pi is equal to 1 over gamma. Gamma is time independent. There's actually no time in JWT star, okay, anywhere. Well, there's time here, sorry. 1 over gamma times lambda over sigma. So this lambda has no time, this sigma has no time. So when they say that it's time independent, that comes from the fact that this lambda and this sigma are time independent, or don't have a time subscript. Now, gamma does, so that's kind of weird. Oh no, because JW and JWW both have the discount factor, so it cancels, and we just get this parameter. So this is actually a parameter. Okay, so I'm wrong. We can't think of this as this ratio anymore, and it is this ratio, but it just ends up being one number after all this cancels out. So there's no time anywhere in this. It's just a risk aversion factor, and then the excess returns, and then the market risk. Okay, so that's interesting. And then the other thing that he wants us to know about is the log investor. So what happens if gamma equals 1? Okay, this is the F-it make money strategy. So the reason that you would split your money between the risky asset and the unrisky asset is that you're afraid of losing too much. And that's what this gamma represents. It's your sensitivity to getting blown out by a big movement in the stock market. So if your gamma equals 1, then your optimal growth, and I'm just writing from the slides now here, because this you can just plug it in and find it from these equations. If we take this optimum pi and we put it back into our wealth equation, you would just get exactly what's written on the slides, which is lambda squared over gamma w dt plus lambda over gamma w dz. So this is the risky part and the risk-free part, the risky part here and the risk-free part. And then if you say, screw it, I don't care about the downside, I only care about the ups. All I see are the ups. So you set your gamma equal to 1, and your wealth equation just becomes r plus lambda squared w dt plus lambda w dz. You put all your money pretty much into the stock market, or as much as possibly makes sense. And this is called the optimum growth portfolio. This was a question on the test last year, FOLIO. Okay. This was a question on the test last year, so you should know what it means. It means that you set your risk parameter to 0, or to 1, I'm sorry, so you don't care about risk. You're not risk loving, okay? You could go lower than 1, and then you would be risk loving. You would get extra utility from being exposed to risk, but by picking it at 1, you're saying, I'm going to pick the portfolio that hedges as little as possible and gets the absolute most upside benefit. And this would be the wealth equation that results from that. Okay, so that is the Black-Scholes world formulation with a solution using the CRRA utility function. So I suppose an extension would be to think about what does it look like with a quadratic utility function. Yeah, so that's all for this series. Talk to you guys later.